Hello, everybody, and welcome to our YouTube channel, which is now called Dream Ed Institute. So today we're going to be treating the topic called mathematical induction. Please, you have to have it in mind that this topic is actually very simple, but then what you need to do is just follow us step by step. We'll be having short videos on this topic. So if you follow us step by step, you're going to get everything easily. Okay, so what is mathematical induction? So anytime you hear mathematical induction, it is just a method used to test for the validity of a mathematical statement. For example, if I tell you that 2 plus 2 equals 4, as a mathematician, you're not supposed to just believe that 2 plus 2 equals 4. You're supposed to test that, okay, is this actually true? So one of the methods that we use to test for when a statement is true in mathematics is mathematical induction, and which is part of the simplest actually. So like I said, it is just used to test for if a statement or a mathematical statement is actually true or not true. So if you want to solve mathematical induction, most questions, I would say 98% of the questions follows this step. It is rare for you to see a question that will not follow this step I want to explain to you. So the 3 steps you're going to be using is number 1, you test, number 2, you assume, and number 3 is induct. Now let me explain it one by one so you don't think it is hard. It's very simple. So when you're given a mathematical expression, a mathematical statement rather, the first thing you need to do, most times when people tell you that you need to just go through 2 steps, but I'm going to try to explain using these 3 steps so you understand without any issue. So the first thing you need to do when you're given a mathematical statement and they ask you to test using mathematical induction or to prove that it is true using mathematical induction, what you need to do is to, number 1, test. Now when they say test in mathematical induction, it means test for when n equals 1 or the base case. Now the base case could be 0, but most times we use if n equals 1, you use it to test. So when you test for n equals 1, that's the first step. If it is correct for n equals 1, then you can move forward to the next step, which is the assumption. In mathematics, when you move to higher level, you're going to have all these assumptions. We have it in mathematics. So now after testing for n equals 1 and you are sure that yes, what I did, n equals 1 is true for this given statement, then you can move to the next thing, which is assumption. You assume that if n equals 1 is true, then let me test for n equals k. Now after that, you have a equation to get. So basically what you need to do is just these 3 steps. This is it, so I won't forget. Anytime you want to solve, number 1, you test for when n equals 1. Number 2, you assume when n equals k. Then number 3, you test, you assume, and then you prove. That means you test that since n equals k is true, then definitely let me test for n equals k plus 1. Because if I have natural numbers, I have 1, 2, 3, 4. If I want to what I mean is if I have natural numbers, I have 1 plus 2 plus 3. Now if I want to get 2, this 2, it means I'm saying 1 plus 1 to give me 2. And if I want to get 3, it means I'm saying 2 plus 1. So it means if something is true for one number, then it has to be true for the number plus 1. So you don't have to stress yourself. This is just a 3 step you need to follow. It's not hard. Number 1, you test if n equals 1. Number 2, you test when you assume n equals k. And number 3, you make assumption that n equals k plus 1. And then most times what you usually do is that you use whatever equation you get in this second step for the third step. Okay, let me take that again just one more time. Okay, so the first thing is you test if n equals 1. Secondly, you assume if n equals k. And the third one is you assume if n equals k plus 1. And most of the time you use whatever equation you have in this second assumption into the third step, and then you prove. It's so simple. So I'm going to be solving 3 out of these examples. As you can see, we have 5 examples here. So I'm going to be solving just 3, and then I'll be expecting everybody to try example 2, because example 2 and example 4 are like similar. Like this is it. I'm going to work on example 1, you work on example 2 because they're actually similar questions. And I'm going to work on example 3, you're going to work on example 4, and then I'm going to work on example 5. So it's very simple. So if you follow me very, very well, you're going to understand it and it's not going to be hard. Now we're going to start with example 1. Okay, now example 1 states, using mathematical induction, prove that 1 plus 2 plus 3 plus up to n is equal to n plus 1 over n plus 1, everything divided by 2. Now, you remember the steps I taught you, right? I said you have to like go through 3 steps, so it's simple. You just have to assume, test if n equals 1, assume if n equals k, and then you induce. So simple, right? Yeah, it's simple. Calm down. Now let's continue. Now, if you test for n equals 1, you know what they gave us is this equation, right? This here. This is what they gave us. And we are asked to prove that we'll have to prove that the left hand side is equal to what? The right hand side. That's just it. Now, if you want to prove that the left hand side is equal to the right hand side, then the first thing you need to do is to test if n equals what? 1. Now, if n equals 1, we have, that means anywhere I see n, both in the left hand side and also in the right hand side, I impute what? 1. So in the left hand side, this is the equation, this is the question, right? So in the left hand side, where do I have n? I have n here. So that means in the left hand side, anywhere I see n, I put 1. Now let me explain why we have 1. This is not you saying 1 plus 2 plus 3 plus dot 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 plus 1, which will give you 2 plus 1 plus 3. No, that's not it. Let me explain. For example, let's say you have chairs. So I'm trying to explain why we have 1 plus 2 plus 3 plus dot 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 plus n to be equal to 1, and not 1 plus 2 plus 3 plus 1. You might be thinking this should be equal to, let's say, 2 plus 1 3 plus 3 6, 10 plus 1 7. What happened to whatever we have in the middle? So the thing is, let me explain this way. These are like set of natural numbers, so it will always give you 1. How? I'm not playing magic here. So let's say I have like a chair. I want to like have rows of chairs. So in the first row I have 1 chair, second row I have 2 chairs, in the third row I have 3 chairs, and in the fourth row I have 4 chairs, for example. So now if I ask you that, okay, what number of chair do you have in the first row? Or like I say chair equals 1, for example. So give me the row that has chair equals 1. What would you say? You just say what? The first one, which is 1. So the thing is, we are not asking you to like add all the number of chairs together. We're only asking you that whenever n equals 1, give me wherever you see n to be equals to 1. That means wherever you see chair equals 1, give me where you have a chair that is equals to 1, which is the first row. So the same thing here now. The left hand side is going to be 1, and then the right hand side, it means anywhere you see n you put 1. So that means I'll have 1 into brackets 1, because this n means 1, this one means we'll put 1 too. So that's why I have 1 into brackets 1 plus 1, everything divided by what? 2. Okay, now here I'll still have 1 equals 1 into bracket, this 1 plus 1 is equal to what? 2. So I'll have 2 divided by 2, then I'll have 1 equals what? 1. Now since my left hand side is equal to right hand side, then I will say, oh, that is true, my test is definitely true. Then it is true that n equals 1 is correct in this given mathematical statement, question. So now I said if n equals 1 is true, then you test for when n equals what? K, don't forget. So now if n equals k, it means anywhere I see n, I put what? K. I don't know if you're getting it. If you have any question, please drop it in the comment box. And also, I'm going to be having the solutions in short videos. So if you want to like get notified when we upload the solutions to other videos, please subscribe to our channel, and also like turn on your notification bell so that you can get notified immediately we post other solutions. So now let me continue. Like I said, if you have any question, just drop it in the comment section. We are going to like answer you immediately. Excuse me. So as I was saying, after you test for if n equals 1, you assume when n equals what? K. Now if n equals k, it means anywhere I see n, I put what? K. So then here I'll have 1 plus 2 plus 3 plus what? K. Then here, instead of me having n, I have k plus 1 over what? 2. Now I just name this anything I like. Now I'm naming it equation what? 1. Can you see? Equation 1. Now the next step is to go to induction. Excuse me. So for induction, like I said, you say let's assume n equals k plus what? 1. So since n equals k is true, we said it is true, we assume that this is what? True. Since we have assumed that this is true, then we also want to assume that n equals k plus 1 should also be true, since it is a natural number, isn't it? So I'll now come here and have my question back. What we need to do, don't forget, is to prove that our left hand side is equal to what? Right hand side. So here I have 1 plus 2 plus 3 plus up to n equals n plus 1 over 2, which is our given question, right? So here, anywhere I see n, I put k plus 1. Now here, I'm going to have 1 plus 2 plus 3 up to... Now, let me show you what I'm trying to explain here. So here, I'm supposed to have 1 plus 2 plus 3 plus dot dot dot. I know you say I should just have k plus 1 here equals k plus 1 into bracket k plus 1 over 2, because I'm using this, isn't it? Anywhere I see n, I use k plus 1, isn't it? But don't forget that before we get to k plus 1, we will definitely have k. What I mean is, now for example, I have 1 here. For me to get to 2, I need to say 1 plus 1. Am I making sense? For me to get to 3, I need to say 2 plus 1. So for me to get to k plus 1, I will definitely need my what? K. That is why here, as you can see, here I have it to be 1 plus 2 plus 3 up to what? K, then up to what? K plus what? 1. Then I'll now say equals k plus 1 into bracket. Anywhere you see any, you put k plus 1, don't forget. So I have k plus 1. Then the one that is left here is what I have here. Okay? Alright, good. Now, let's now start to solve mathematically, gently. So, don't forget that this expression here, this whole expression you have here, is what we have as equation 1. Look at it. 1 plus 2 plus 3 plus up to k is equal to what? Whatever I have here. K plus 1 over what? 2, which is what I have here now. Plus k plus 1 equals what? What we have now, right hand side. Now let's find the LCM for the left hand side. If you look at it, this is over what? 1. If I do the LCM, then I will have what? 2. Then this will be k plus 1 plus, this is 1. So therefore, I'm going to have 2 into bracket k plus 1 equals to our what? Right hand side. I hope you get it. So afterwards, then you continue. Since we have this now, if you look at it, it's the same thing. I didn't jump. From here, we have this. So you now factorize. Factorize means you bring out what is common. Do you get? So if you look at this left hand side now, you have k plus 1 to be common to both. Like here now, k plus 1 is in this first state, in this first part, and k plus 1 is also in the second part. I hope you are following. If you have any question, please drop it in the comment section. We're going to get back to you immediately. Now the next thing is, I said factorize, right? So what is common to these two things is what? K plus 1. Then I open my bracket. So what I'll be left with in this first one now, let me show you. So as you can see, we have k for the first one, k plus 1. If I divide it by k plus 1, I'll be left with just what? K. Okay, for the second one, I have 2 k plus 1 divided by this k plus 1. I'll be left with what? 2. Can you see? That's why I have it to be k plus 1 into bracket k plus 2 over what 2. Now the thing is, if you open this bracket, you have this back. So for you to check if you are correct or wrong, then you equals to our right hand side back. Now if you look at the left hand side, I just had to rewrite it. So you have k plus 1 into bracket k plus 2 over 2 equals k plus 1 into bracket k plus 2 over 2. Now since your left hand side is equal to right hand side, do you know what we did? Let me show you again. All we just did was to prove from our left hand side that okay, we want to show that our left hand side equals to right hand side. So what we just did was try to solve the left hand side so that it will look like what we have on the right hand side, and voila, this is it. We have our k plus 1 k plus 2 over 2 equals to the same thing that we have in the right hand side. Now since this is true, then we say that the mathematical equation or statement is what? True. Okay, I hope you understand. So in summary, when you want to solve any kind of equation, mathematical induction, most times, so you first thing you do is to test, then you assume, and then you induce. Don't forget, test, assume, induce. Test for n equals 1, assume for n equals to k, assume for n equals to k plus 1. Induce means you put in your assumption into the third step, and then you solve easily. That way, if you're able to prove that your left hand side is equal to the right hand side, then you see that that thing or that equation is actually true. Thank you for watching this session, and join us in the next session for you to be able to get the solution to the next example. Don't forget to subscribe to our channel and also turn on your notification bell to get notified immediately we have the solution to this question. All right guys, have a nice day. Bye.